Welcome to Are You Chemistry GCSE Ready? This playlist takes you through loads of example questions and guided solutions for every single topic in your chemistry GCSE. So it's a perfect way for you to test your chemistry knowledge. If you feel like you need a quick review or you just want the ideal revision companion for these videos, then make sure to download my free chemistry GCSE revision notes. I've linked them in the description below. Or if you're ready, let's dive straight in.
Mass, moles and Avogadro's number. So what do we use to convert between mass and moles? We can maybe remember this triangle that is in your notes. Mass, moles, and then this RFM or RAM. And we need to use these three things to kind of move between the two. So if I want to get from mass into moles, I take my mass and I would divide through by, well, it depends, I suppose. If they're a compound, I divide through by the relative formula mass. And if it weren't a compound, then I divide by the relative atomic mass. And that would give me the number of moles. If, however, I had the number of moles and I had something like here, the relative atomic mass, then I multiply those two together to give me the mass of my substance. What's Avogadro's number and how can we use it? Well, what is it first? It's 6.02 times 10 to the 23. And it looks kind of scary, but the important thing to remember is it is just a number of things, sometimes given the symbol capital N and an underscript A. It's always given to you in the question, so you won't have to memorize it. And it's the number of things in a mole. So just like the number of things in a dozen is 12 things in a dozen, the number of things in a mole is 6.02 times 10 to the 23. So a lot more things in a mole, but still it works in the same way. Okay, so let's use it. How many moles of copper atoms are in 63.5 kilograms of copper? So first things first, I want my mass in grams, and I know there are 1,000 grams in a kilogram. So I take my mass in kilograms, multiply by 1,000, and that will give me my mass of copper in grams. So 63.5 kilograms times 1,000 is 63,500 grams. Then I use my triangle formula. So I wanted the number of moles, so I cover that up, and that gives me, it's going to be my mass divided by my relative atomic mass for my number of moles. The relative atomic mass of copper is 63.5. You can find that in your periodic table. So let's do it then. Mass 63,500 divided by RAM 63.5 gives me 1,000 moles of copper in 63.5 kilograms of copper. Okay, how many bromide ions are there in 6.5 moles of aluminium bromide? Give your answer to 2 decimal places. So if you look at the formula for aluminium bromide there, we've got AlBr3. So that is telling me that in one aluminium bromide, there are actually 3 bromide ions, which means in 6.5 moles of aluminium bromide, there are 3 times that. 6.5 times 3 is 19.5 moles of bromide in that. And so how do I find out how many ions there are if there are that number of moles? Well, you take the number of moles, 19.5, and you multiply by Avogadro's number, 6.02 times 10 to the 23, 1.1739 times 10 to the 25 bromide ions. Combination questions. How many moles of hydrogen atoms are there in 5 grams of ammonium sulfide? And we're given the formula for ammonium sulfide and some relative atomic masses for nitrogen, hydrogen, and sulfur. Give your answer to 2DP. So first things first, we need to work out what the relative formula mass is of ammonium sulfide. And I do that by looking at the formula and thinking to myself, okay, I've got NH4, and then there's the brackets and the 2 at the bottom. So I've got 2 of those ammonium ions, which means in total then, I have got 2 nitrogen, I've got 8, which is the little 4 at the bottom of the hydrogen there, multiplied by 2, 8 hydrogen, and 1 sulfur in ammonium sulfide. So to find the relative formula mass, 2 times 14 plus 8 times 1. These are all just doing that number times the relative atomic mass of each of these. So 1 sulfur times 32, its relative atomic mass, added them together is 68. Now to find out how many moles I have of ammonium sulfide and 5 grams of it, well, if I do the mass divided by the relative formula mass, that gives me my number of moles. So 5 grams from the question divided by 68 gives me 0.0735294. And that's my moles of ammonium sulfide. However, I was asked how many moles of hydrogen atoms there are. And the thing is, because I was looking at this formula, what I know is that for 1 mole, let's say, of ammonium sulfide, that requires 8 moles of hydrogen atoms. So if there are 0.0735294 moles of ammonium sulfide, if I multiply it by 8, that's 0.588235 moles of hydrogen atoms. To 2 decimal places, that would be 0.59 moles of hydrogen atoms. And just to show you here, if I wanted to know how many atoms of hydrogen that actually is, then I take the number of moles and I multiply by Avogadro's number 6.02 times 10 to 23 to give me 3.54 times 10 to the 23 atoms of hydrogen.
Just before we go into the tips and tricks section, if you do want some extra advice to getting that grade 9 for your GCSE, then why not download my free 20-minute exam success guide? Just click on the link in the description below. I'm going to give away all of my best advice and secrets and completely for free, so why not?
Okay, tips and tricks. So make sure you're confident at working out formula for different substances so that you can work out their relative formula mass. Yeah, you first need to know how many of each different ion or atom there are in a particular substance so that you can use those individual relative atomic masses to work out the relative formula mass for a particular compound. Be careful when dealing with brackets in the formula when working out RFM. The brackets work the same way that they would in a maths lesson. So, for example, here, how many oxygen atoms in CaOH2? Because that OH is bracketed and the 2's at the bottom, you multiply both the O by 2 and the H by 2. So there are 2 oxygen atoms there. If you're not sure how to approach a question, maybe try swapping out some of the words for more familiar words. So if it says moles, maybe try swapping out the idea of dozens, see if that helps you. And diatomic molecules, maybe pairs of socks. Okay, that was the example in the notes, to try and help you and draw some analogies.